Now let us talk about groups and periods of modern periodic table. As we have already discussed that the vertical columns are called groups and the horizontal rows are called periods. There are total 18 groups and total 7 periods in the modern periodic table. Students, there are different names assigned to these groups, but here we will not remember the names of groups, only we will remember the number, group 1, group 2, group 3 and so on. When you will go in higher standards, there you will study the names also. Now let us look at the elements present in group number 1. What are they? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Let us try to correlate these properties of elements. First element is hydrogen. Now we know that the elements are arranged in their increasing order of atomic number. Here you need to remember that for all the elements, number of protons and number of electrons will be equal. Please keep this in mind. So when we talk that hydrogen has atomic number 1, which means number of proton is 1. That means also hydrogen has 1 electron. Okay. Atomic number is number of proton, but for all elements, number of protons and number of electrons will be equal. So please keep this in mind. And when we draw electronic configuration, there what do we represent? Electrons, right? So when we draw electronic configuration of hydrogen, it will have one shell, that is K, in which 1 electron will be kept. If I ask you what is the outermost orbit, or else how many electrons are present in outermost orbit of hydrogen, what will be the answer? 1. Okay, because hydrogen has only 1 electron, so that will be its electron in outermost orbit. We also call it as valence electron. If we talk about lithium, atomic number of lithium is 3, which means 2 electrons will be filled in first orbit and in second orbit 1 electron. How many electrons are present in outermost orbit? 1 electron. If I talk about sodium, it has atomic number 11. So in first orbit 2, in second orbit 8 and in last orbit, third orbit 1 electron. If I talk about potassium, it has atomic number 19. So in first orbit 2, second orbit 8, third orbit 8 and next orbit 1 electron. If I talk about rubidium, it has atomic number 37. So arrangement of electrons will be 2, 8, 18, 8 and 1. If we talk about cesium, it has atomic number 55. If we talk about francium, it has atomic number 87. Here in this all arrangements of electrons, one thing is common. If you have noticed, all these elements have 1 electron only in outermost orbit. So this is the first common property of the elements present in group. This we have talked for first group, but this will be same for all. Okay, this property will be same for all the elements present in one group. For example, here in group 1, we have 1 electron in outermost orbit for all elements. As you have observed that for every element, 1 electron is valence electron. Okay, this we have talked for group number 1. Same way, if you take another group, let us talk about second group. So the elements which are present in second group, they all will have same number of valence electron. That doesn't mean that they have one electron in outermost orbit. Okay, I tell you, for group 1, the elements have one valence electron. Okay, for group number 2, they have two valence electrons. Now directly we'll talk for group number 13. It has 3 valence electrons. Group number 14 has 4 electrons. Group number 15 has 5 valence electron. Group number 16 has 6 valence electron. Group number 17 has 7 valence electron. And group number 18 has 8 valence electrons, which means electrons in outermost orbit. So this way, elements in same group will have same number of valence electron, as we have seen. So this is the first property which you will remember, that all the elements present in same group will have same number of valence electrons. Now let us talk about group number 17. What are the elements of group number 17? Fluorine, chlorine, bromine, iodine, etc. Now, before in this chapter only, we have little talk about halogens. Okay, they are what? Non-metals. When we were learning limitations of Mendeleev's periodic table, that time we have talked for this. Now, let us here try to correlate the properties of these elements. The first element is fluorine. Atomic number of fluorine is 9. 2 electrons in first orbit, 7 electrons in second orbit. The next we have chlorine. Atomic number 17. 2 in first orbit, 8 electrons in second, and in last orbit 7 electrons. Here for fluorine, valence electrons are 7. For chlorine, valence electrons are 7. If we talk about bromine, the atomic number of bromine is 35. So if we arrange electrons in different shells, it will be 2, 8, 18 and 7. Here also we can see there are 7 electrons in outermost orbit. If we talk about iodine, atomic number of iodine is 53. So the arrangement of electron will be 2, 8, 18, 18 and 7. Here also you can see that there are 7 electrons in outermost orbit. So from this also we can see all the elements have same number of valence electrons, which means elements in the same group will have same number of electrons in outermost orbit, that is valence electron. So that is true for group number 17 also. We have already looked at group number 1. You can check for all other groups also. So from this we came to conclusion that elements present in same group will have same valence electrons. Also, we can say that the groups in periodic table signify an identical outer shell electronic configuration, which means same only, identical outer shell electronic configuration, which means groups say us the number of valence electrons, the number of electrons present in outermost shell. From the group only we can identify easily. Okay, as I said you before that group 1 has 1 valence electron, group 2 has 2 valence electron, group 13 has 3 valence electron, like this. So from this we can say that in groups we can easily identify the number of valence electrons. Here you need to note that as we go down in the group, the number of shells increases. What does that mean? Let us take example. If we talk about first group, for hydrogen, one shell was there. Okay. For lithium, two shells were there, K and L. Okay. For sodium, three shells were there. This way, the number of shells increases as we go top to down in the group. If we talk about group number 17, then fluorine has two shells. Then chlorine has three shells. Then bromine has four shells. This way, the number of shells increases as we go from top to bottom. You will be thinking, why is it so? It has a simple reason, that the elements are arranged in increasing order of their atomic number, which means the atoms will have increasing atomic number. So after one by one, the number will increase. So obviously, if the number of protons will increase, number of electrons will also increase, and as number of electron increasing, we need to have different shells. So number of shells were also increased. Okay, so this is simple reason that number of protons are increased, so number of electrons are increased, and to fill the electrons in shells, we need to increase the different shells also. Okay. So from this, two things we learned, that the elements in same group will have same number of valence electron, and second thing, that as we go down in the group, the number of shells increases. Okay, so these two things we have got.